Hello and welcome to some more maths with Mr. Thompson, and today we're looking at probability trees. Now what probability trees are just a way of representing a sequence of probability events. They're handy if there's not too many events, there's not too many options. If the numbers get a bit big, then they're not usually the best way to go, but often for the level we're at, they're a nice way to represent some probability structure. So let's just dive into an example. Here's a classic example here. So just to be clear that independent events are what we're looking at. That's quite important, and we'll find out more about them as the course continues. But this is a classic case that we use for probability trees. We've got a bag containing 5 red balls, 3 white balls and a blue ball. And we're going to draw from the bag twice. The first time we do it, we're going to draw a ball out, look at its colour, replace it, see what we get, then draw a second ball out, and wonder what the chances are of getting 2 red balls. The second time we do it, we're going to do it, but after we take the first ball out, we're not going to replace it. And we're going to see what the chances of getting 2 red balls there when we don't replace the ball after the first draw. I'll show you what I mean. So here we go, 5 red, 3 white and 1 blue, and we start off by drawing a probability tree now. On the first event, we can draw either a red ball, a white ball, or a blue ball. And on the branches, we write what the chances are of these things happening. Well, as you can see, we've got 5 red out of a total of 9. So the chances of getting red are 5 over 9. When it comes to white, when it comes to doing white, well, we've got 3 white, we've got 3 white out of 9. So I've got a chance of getting 3 out of 9 white. For blue, we've got 1 blue ball out of 9, so there's 1 chance in 9 of getting a blue ball, okay? So let's say that happens, one of those 3 things happened, and we record the colour, and then we put the ball back in, and we repeat the process. Now, so if we got a red ball the first time, and once again we get 3 options, we can get either red, white or blue. If we did white the first time, again we get 3 options, red, white or blue. And if we got blue the first time, we can still get red, white or blue the second time. And what are the odds this time? Well, the probabilities for each of these are exactly the same as they were before, because we have replaced the ball. So it's 5 ninths there, 3 ninths there, and 1 ninth there. 5 ninths, 3 ninths, and 1 ninth. And now, if we want to find the probability of going red, red, we follow the red arm twice, and we multiply the numbers together, and that gives us the probability of getting 2 red balls of 25 over 81. Suppose we wanted to find the chances of going white-blue. That'd be that arm there. That'd be 3 ninths times 1 ninth, which is 4 over 81. Supposing I wanted white-blue in either order, in which case, yes, we would have that one, or we could have that one followed by that one, couldn't we? We could go blue-white, which is 1 ninth times 3 ninths, which is 4 over 81. And if you wanted either of these 2 situations, if it was that or that one, we'd add them up to get 8 over 81. Let's consider the same situation, but this time we replace the ball after the first draw. So the first time out, the bag is exactly as it was the first time. Red, white and blue. Red, chances is 5 out of 9. White, the chances is 3 out of 9. And blue, the chances is 1 out of 9. For my second draw, we need to be a bit more careful here this time. I'm not replacing the red ball that I've just drawn back here. So that means there's only 4 red balls left in the bag. Not only that, there's only 8 balls left in the bag altogether, because we didn't replace it. If we drew a red the first time, the chance of getting a white, well, there's still 3 white left in the bag, but there's only 8 balls left. Similarly for blue, there's 1 blue left, but there's only 8 balls left in total. Let's see what happens if we continue this down for the remaining ones. Well, if we drew a white the first time, then that's okay. There's still 5 red. Oops, excuse me. There's still 5 red, but only 8 balls. If we drew a white the first time, there's only 2 white left out of the 8 balls, but there's still 1 blue left out of the 8 balls. What if we drew a blue ball? Well, we'd have 5 red out of 8. We'd have 3 white out of 8, but the blue ball would have gone completely. There is 0 chance of getting a blue ball on the second draw. So you see how these probabilities change on the arms because you didn't replace the ball, okay? The top number changes if that was the colour drawn, and the bottom number always changes regardless of the colour drawn. So if we're doing our red time chances this time, it's 5 over 9 times 4 over 8, which is 20 over 72. And just for interest, let's look at our white-blue combination. White-blue is 3/9 times 1/8, which is 3 over 72. And blue-white is 1/9 times 3/8, which is 3 over 72. And again, we want either of these two. So that would be 3 72s plus 3 over 73, which is 6 over 72. And that's the basic probability tree diagrams.